Okay, so today we're going to be looking at a more applicable part of linear programming, which is just basically continuing on 3.3 with graphing inequalities. And this is much more of a real life application of graphing or linear inequality systems. Okay, so you have some blanks to fill in on your notes page. Excuse me. In business, we try to maximize profits, but minimize costs. The quantity that we want to be maximized is called the objective function. And that always looks like an equation like P equals 2x plus y, or something like that. There's always restrictions on your profits and your costs. Those restrictions are called constraints. The constraints are represented by a system of linear inequalities, which is what we were graphing earlier in 3.3. The graph of your linear system constraints, the solution, is called the feasible region. So that area that is completely shaded in by all the different graphs, that's your feasible region. What's cool about that feasible region is that's all of your solutions. All of those could be possible maximum or minimum values. But what we find is that your maximum or minimum value always occurs at the vertices of the feasible region. So today, what we will be doing is graphing linear systems, finding the vertices of where all those lines intersect, and then we will be plugging those vertices into our objective function and finding it, which is our maximum and minimum value. Okay, so example 1, it says find the maximum and minimum value for this objective, P equals 2x plus y, under these constraints. So let me write my objective function again because I'm going to need that here in a minute. All right. First, what we're going to do is we're going to graph the constraints. So notice we've got x is greater than or equal to 0 and y is greater than or equal to 0, which means we're going to be strictly in quadrant 1. Okay, feasible region is going to be quadrant 1. All right, now let's graph the other two. Y is greater than or equal to 2x minus 2. That's going to be down 2, which is off my graph, but it's okay. And I'm going to go up 2 over 1 using my slope, and I'm going to plot several of those points. That's going to be a solid line, and since it's greater than, I want everything above that. And I'm going to stop at the y and x axis because I know that my third and fourth equations say it has to stop there. Alright, y is less than or equal to negative x plus 4, y-intercept at plus 4, down 1 over 1. Again, I'm going to continue to plot points. Makes it easier to determine my vertices that way. Solid line, it's less than, so everything's shaded below. Now, my feasible region is where those two plus the x is greater than or equal to 0 and y is greater than or equal to 0 intersect. So that's the black area that I'm coloring. My vertices are here, these 4 points. Alright, so now what I'm going to do is I'm going to test each vertex in the objective function. So let me write those down. They are 0, 0, 0, 4, 1, 0, and 2, 2. Alright, and I'm just going to plug in each x and y pair into the objective function. So it's going to give me 2 times 0 plus 0 is 0. 2 times 0 plus 4, let me go ahead and write this out so we don't get lost, is 4. 2 times 1 plus 0 is 2. And then 2 times 2 plus 2 is 6. So the one that gives me the maximum value is the point 2, 2. So this is my max. The one that gives me my minimum value is the 0.00, so that is my min. Okay, so we've got this potter. He wants to make and sell serving bowls and plates. He can make a bowl using 5 pounds of clay, and he can make a plate using, we need to change this number in our notes to 4 pounds of clay. The potter has 40 pounds total that he wants to make at least 4 bowls. Okay, so first thing, we're going to kind of describe for ourselves what we are doing. We're going to define the number of bowls as X, which we know takes 5 pounds of clay for each one. We're going to define the number of plates as Y, and they use up 4 pounds of clay for each one. All right, our restraints have to be these. X is greater than or equal to 4 because he wants to make at least 4 bowls. Y has to be greater than or equal to 0 because he cannot have negative plates. And then he cannot use any more than 40 pounds. So 5 pounds of clay per bowl plus 4 pounds of clay per plate has to be less than or equal to 40. Now, this is a given. It wasn't exactly written in our problem, but we know that 35 is the profit that he makes for a bowl. 40 is the profit that he makes for a plate. So therefore, our objective function is this guy right here. Okay. If you look at the graph, notice that I've filled in a lot of the blanks already for you. We've already done the graph. I've already colored in the feasible region for you. All we need to do now is plug in the vertices, so 4, 0, 8, 0, and 4, 5, into our function 35x plus 30y, and then see what our maximum is. So we've got 35 times 4 plus 30 times 0. That's going to be 140. 35 times 8 plus 30 times 0 is 280. 35 times 4 plus 30 times 5, that's going to be 140 again, plus 150, so 290. So maximum profit is $290, which for our potter means that he needs to make 4, what is X? Plates? Bowls. 4 bowls and 5 plates. All right, so last example, it says to find the min and max value for this function using these restraints. Okay, so X is greater than or equal to 0, Y is greater than or equal to 0. I want to point out to you guys that my y-intercept for that last line is 35. So I'm looking at this and I'm thinking, if I have to have X is greater than or equal to 0 and Y is greater than or equal to 0, I don't need quadrants 2 through 4. So I'm going to redraw this graph to make this point be the origin. That way I have more room to graph. Alright, if I'm going to graph the equation x plus 2y is less than or equal to 16, when I solve that equation for y, y is less than or equal to negative 1/2 x plus 8. There we go. Alright, now I'm going to plot that. I'm going to go by ones. So up 1, 2, 3, 4, 5, 6, 7, 8. Down 1 over 2. And again, I'm plotting as many points as I can because it makes finding those vertices so much easier. Solid line, it's less than, so I'm going to shade below. Alright, the other equation, if I solve that one for y, I get y is less than or equal to negative 5x plus 35, which is way up there. So let's think. This is 10. This is 20. Maybe I can find the x-intercept instead and then use my -5 slope to find another point. My x-intercept would be, if I plug in 0 for y, cover that up, my x-intercept is the point 70. So I'm going to plot that point, 7, 0, and then go up 5 over 1. Oh, looky there. I have my vertex. And just stop right there. Okay. Now I shade that in. My feasible region is where the two colored areas overlap, so that is now being colored in black. Okay, so I'm going to have to scoot this up so I can write some. My cost function, objective function, is C equals 4x plus 5y. Let me double check that. Yep. And then I need to write down my vertices. My vertices are 0, 0, 8, 0. This point is 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5. 6, 5. And then, let's see, it would have to be this point here, which was my y-intercept. Did I already get that one? Oh, I said 8, 0. That should have been 0, 8. And then this one is 8, 0, or 7, 0, sorry. Okay, plugging in x's and y's, this would be 0 plus 0, which is 0. This would be 0 plus 5 times 8 would be 40, which is 40. This would be 4 times 6 plus 5 times 5, which would be 24 plus 25 is 49. And this would be 4 times 7, which is 28, plus 0, which is 28. So my maximum is 6, 5. So what that means for my Potter is, or I'm not doing a Potter example this time, am I? Nope, that means just that my maximum is 6, 5. I need to find the minimum. My minimum is, I'm going to label this one max. My minimum is 0, 0. All right, so your is to help out Mr. Ramirez, because Mr. Ramirez is a great artist, but he's horrible at math. So help him to find a way to maximize his profits for creating murals. Mr. Ramirez creates murals for people sometimes, and he wants to make money off of them. So write a word problem similar to the Potter problem. You're not actually going to solve this. Just make up some numbers. See if you can come up with a reasonable word problem that would need to be solved by linear programming. Instead of plates and bowls, use the number of feet of the mural that's painted and the time required. Be sure to include restraints. For example, it must be at least, I'm going to change that wording right there, 5 feet long. Because that would be a greater than or equal to. So we would write this as x is greater than or equal to 5. And your assignment for today is a worksheet that the substitute's going to hand out, and that is due tomorrow. Good luck.